You're here now for Getting Started with Raspberry Pi. It's a 15-minute whirlwind tour of the Raspberry Pi, everything you need to know to get started with it. So what you need to have, how it works, what the parts are, and what it's capable of, and what kind of cool Raspberry Pi projects you can see all around Maker Faire. So as I said, my name is Matt Richardson. I'm a contributing editor for Make. I'm also the author of Getting Started with Raspberry Pi, a book I co-authored with my good friend Sean Wallace. If you're interested in what I'm talking about and you're interested in knowing more about Raspberry Pi, there's a ton of good information in here. This is available in the Maker Shed, and it's also available online. So what is a Raspberry Pi? Essentially, Raspberry Pi is just a computer. You can plug in a keyboard, monitor, mouse, and you can use it like you'd use any other kind of computer. Now, you can also plug it into the internet and get it online. So you could just surf the web on this if you wanted to. Now, it was a computer that was designed for educational use by a nonprofit foundation in the United Kingdom, but luckily all of us can buy them. It's not just restricted for educational use, and in fact, makers love Raspberry Pi as well. Now, if you want to talk about specs a little bit here, at the core of the Raspberry Pi is a processor. It's a lot like the processor you'll find in a cell phone. In fact, like an older cell phone, maybe a first-generation iPhone. If you like the nitty-gritty specs, it's a 700 megahertz ARM11 processor. It has 512 megabytes of RAM in the Model B. There are two video outputs on the Raspberry Pi. The one on the bottom that you see is an HDMI video output. You see HDMI connections on all modern television sets these days, and you see them also on computer monitors as well. That's how you'll connect it to a monitor. You also have a composite video out. That's an analog output, and that should look familiar to you. It's the kind of video input you'll still see on TVs, but they're kind of fading away now, and you don't see them as frequently. But if you have an analog TV, or a digital TV, or a digital monitor, you can connect it to the Raspberry Pi with either of these connections. There's a USB port. There are two USB ports on the Raspberry Pi on Model A. This is how you're going to connect a keyboard or mouse. You can also connect any kind of USB peripheral. If you have a USB webcam, you can connect that to the Raspberry Pi as well. You can also connect little Wi-Fi dongles. Most USB devices will connect to the Raspberry Pi, and you'll be able to use them in one way or another. As I mentioned, it can get online. And on the Raspberry Pi, there's an Ethernet port. So you can connect it to your wired Ethernet and your wired network that way so you can get your Raspberry Pi online. If you don't want to connect it to if you don't have access to a wired network, you can also use one of those USB Wi-Fi dongles. You plug it in there, as I mentioned before. Those are pretty cheap. Those are only about $10 if you want to get the Raspberry Pi onto a Wi-Fi network. There's a little power jack on the bottom left side of the board. It looks like it's a micro USB port, so it's the kind of USB port you'll find on some devices like cell phones, but it's only going to get power through this port. So this is how you get power. You'll need a micro USB cable. It doesn't do any kind of like USB communication. It won't talk to your computer through this port. It only gets power through it. There's also an audio jack if you want to connect speakers or make a sound project with Raspberry Pi. And there's this interesting connector called the camera serial interface. Now, inside your cell phone, there's a board, and that board connects to a separate camera board through a connector. Now, we usually, as normal consumers, don't use a connector like this because it's something that's usually already connected inside a product like a cell phone. But we have access to it on the Raspberry Pi, and if you want to get a camera that connects to this port, they're available from the Raspberry Pi Foundation. They have an official camera board that connects to the Raspberry Pi through that port. But you can also use a USB webcam and find an old one on the junk shelf if you have one to plug in if you want to do a camera project with the Raspberry Pi. One of my favorite features of the Raspberry Pi are these pins that are along the top up here. These are GPIO pins. They're called General Purpose Input and Output pins. Now, who here has an Arduino or has worked with an Arduino before? Okay, so on the Arduino you have these pins, these GPIO pins. Now these pins are pins that you can control, you can turn things on and off, or you can listen to whether they're on or off. And the same is true with the Raspberry Pi. If you hook up a switch to these pins, you can use software to check whether the switch is turned on or off. Or if you have an LED or a lamp or a motor, you can turn those devices on and off with these pins. That makes it a little bit different than a normal computer. These pins are why we like Raspberry Pi as makers, because it lets us integrate this into our projects. And we can, if we're building something with electronics, it makes it easy just to attach a computer to the project. I think, though, the best feature of the Raspberry Pi is its price. Now, I don't work for the Raspberry Pi Foundation. I don't gain any benefit by trying to sell it to you, but I think it's fantastic that the price is so low. It means that it's not that expensive if you want to integrate a full-on computer into your project. If you've got a project that you're building and you know you want to dedicate a computer to it, you don't have to take a computer away from anything else. It's just a $35 component. In some cases, it could be one of the cheaper components in your project. And if $35 is too much, I know I'm sounding a little bit like an infomercial here, there's also a $25 model that has only one USB port here. It doesn't have the Ethernet jack, and it has half the amount of memory that the Model B has. And this cheaper version, this less expensive version, is called the Model A. The Model A has an advantage in that not only is it less expensive, but it also uses less power than the Model B. So if you're dedicating your Raspberry Pi to a project, and you don't need Ethernet, and you don't need a lot of memory, you may want to consider using the Model B. You'll save some money, and you'll save some power. I think this idea of a less expensive computer board like this is very, very important. And Linus Torvalds said to BBC News, "I find things like Raspberry Pi to be an important thing, trying to make it possible for a wider group of people to tinker with computers and just playing around, and making the computers cheap enough that you can not only afford the hardware at a big scale, but you also, perhaps more importantly, afford failure." And I think that's really what it's all about, is being able to afford failure. You can experiment with the Raspberry Pi with impunity. You don't have to worry about breaking something that's expensive. If you do, first of all, it's really hard to break something like this. I mean, I've done some crazy stuff to my Raspberry Pis. I haven't broken a single one of them yet. But you can experiment and not worry about if you're going to break it or not, because if you do, it was only $35. Now, that quote is from Linus Torvalds. He's the founder of Linux, which is the free and open source operating system, which is what the Raspberry Pi runs on. Just like your computer may have Mac OS or Windows, Raspberry Pi most of the time runs on Linux, and it has a desktop environment just like Mac or Windows. So you can use your keyboard and mouse, it has a web browser and everything. You don't have to use the desktop environment if you don't want to. You can just use it if you're comfortable using the command line terminal and just text input if you'd like. There are other operating systems you can load onto the Raspberry Pi, but the Raspberry Pi Foundation provides an official distribution called Raspbian, which you can load on, and it's fully supported, and that's where most people are using Raspberry Pi. It's the software most people use. I want to show you a few things that you're going to need to work with Raspberry Pi so that you can get started really quickly. For one, you'll need a USB charger like this. Most cell phone chargers will be okay, but you want to look out for one thing. It's got to be 5 volts, and it's got to provide enough current. And you'll see that it'll say 1A after the output there. That means 1 amp. You need about 1 amp to run Raspberry Pi, and not all 5-volt chargers will give 1 amp. It may also say 1000 mA, that's milliamps, it's the same thing. You can go as low as 700 milliamps or 0.7 amps, but you may run into some weird behavior if you plug in a lot of devices or you're using a lot of power on the Pi. Of course, to connect that power supply to the unit, you'll need a USB cable. It has to have a micro USB hook on the other side so that you can hook it up here. And instead of a hard drive, the Raspberry Pi uses an SD card. This is exactly like the kind of SD card you're going to put into your digital camera. And what's cool about it is it's the same kind of SD card you can buy in a drugstore nowadays. So if you ever fry one of these, and I have messed up my SD cards before by messing around with things I shouldn't have been, you can just go, you can reflash it, you can put new operating system on it, and if you really mess it up, you can just buy a new one as well. And these are cheap. Of course, a USB keyboard and mouse, those are very helpful if you're getting started because then it'll work just like a normal computer. A monitor, either an analog monitor or a digital one is fine. It has HDMI and composite out, as I pointed out before. Now, you don't have to have a case, but I think cases are really nice to have. This one I'm showing on screen, and the one I have in my hand here, this is from Adafruit. Pimeroni over there, they sell some amazing rainbow-colored cases that are pretty cool as well. There are cases available in the Maker Shed. As I said, you don't have to have a case, and you don't have to buy a case. But if you don't want to buy a case, you can also make a case out of Lego if you want. So if you're going to work with the Raspberry Pi, you're probably going to want to program it. You're going to want to make it do the things you want to do. There are a few different ways to do it. For one, there's an open source programming environment that's aimed at younger kids who are just learning programming. It's called Scratch. It's like a drag and drop programming environment where you use your mouse and keyboard, where you can drag things around and you can animate a little character on a stage. If you're a little bit more advanced, you can use languages like C, Python, Java, all of those will work. And if you haven't written a line of code in your life and you want to get started, I recommend checking out how well Python works on the Raspberry Pi. So let me show you a couple quick projects before I have to get off stage. I wanted to integrate the Raspberry Pi into my bike. I bike around New York City, and I wanted to get some information about my ride while I was riding. So I built what I call a dynamic bike headlight. I strapped a Raspberry Pi to the bike, gave it a battery, and I added some circuitry so that there was a sensor on the wheel so I could tell how fast the wheel was going. I connected it to a projector, a battery-operated projector on the front handle bike of the handlebars, and I took it out on the street. It's a dynamic bike headlight, so it was showing me the speed of my bike ride in the beam of the headlight as I bike around. Now, I'm normally a pretty conscientious cyclist, and I stick to the bike lanes, but for this demo, I had the camera right where my torso is supposed to be, and I'm stretching around it, and I'm kind of like teetering back and forth. I'm usually a much better cyclist than this, but this gives you a good idea of the first-person point of view when you're using this. Now, it doesn't have to show the speed of the bike. If you added a GPS chip and you added the right programming, it could give you navigation instructions, when to take a left, when to take a right. It could show text messages. It could show you how many calories you burn, what your altitude is, how far you've gone, any number of things this dynamic bike headlight could show. Here at Maker Faire, there's a ton of awesome Raspberry Pi projects. There's down in the, if you go inside NYSCI, inside Zone A, and you go downstairs, there's a ton of great makers, many of them using Raspberry Pi. One of them is Tom Calloway from the Fedora project. He's showing off a Pi-based 3D printer. Also, a local hackerspace, NYC Resistor, set up their interactive multiplayer game called Future Crew, where you have these old antique devices that you can plug different things into, and there's a whole game involved. You want to check that out. It's also inside NYSCI. So there are plenty of awesome Raspberry Pi projects to check out around Maker Faire. I recommend just exploring. You'll see it everywhere. If you want to find out more about Raspberry Pi, the book is available online. It's also available here in the Maker Shed. I don't have much time left. I want to let the next presenter get set up. So I'm going to step aside here if you have any questions, and we can talk all about Raspberry Pi. Thanks for coming, and have a great time at Maker Faire.